the most important things to know when you learn a new programming language is what are the data types that it includes. And then to become proficient at that language, you should learn to choose the right data type for any problem that you have to tackle. So we are going to start here by learning all of the built-in data types that are included with Python. This diagram shows all of Python's built-in data types. And by built-in, of course, I mean these are the ones that are available to you when you fire up an interpreter without having to import them separately. And we split them into two categories, the scalars and the collections. So scalars are individual pieces of data, like individual numbers, where collections, as the name implies, are collections of numbers or data objects. And the difference between the different collections are in how those objects or numbers are organized into lists, tuples, sets, etc. And we will learn more about collections in the next module. In this module, we're going to focus on the scalars. And those are 5 scalar types: integer, floats, complex, booleans, and none types. So the integers, as you probably know, are just the whole numbers. We have, let's say, -2 is an integer. So is -1, 0, 1, 2, and so forth, up to a very large whole number, and backward down to a very negative whole number. Then a float is like a real number. So 2.175 is a float. So is -15.67. And also -16.0 is a float and not an integer if you explicitly indicate the point 0. So let's have a quick look at that. Here we have an empty Jupyter notebook, and we can add some code such as a is equal to 4 again, and then we can ask for the type of a. So type is a built-in function that gives us that looks at the variable and tells us what type of data type it is. Okay, so we get that a is an integer, as we expected. What if we said 4.4? It will tell us that it's a float. What if we say 4.0? It's still a float. Now, what if we define another number, another variable called b, and we ask for the type of b? It's an integer. Now, let's do something interesting. Let's define c as a plus b. So now we are adding a float and an integer. What do you think it's the type of c is going to be? It's a float. So if you add an integer with a float, you get a float. Okay, our next type is the complex number. A complex number, as you know, is one that has an imaginary part to it. So it lives somewhere in the complex plane. And so let's say, for example, that number in the complex plane is a complex number equal to maybe -1, -1j. So we use in Python the letter j to denote the square root of -1. Okay, let's try that. So let's make a new cell here, and let's make a new variable d is equal to 1 plus 8j. Oops, j. Okay, so this is interpreted as a complex number. Notice that I did not do 8 times j, where the asterisk is for the time symbol. That's because if I did that, then it would expect that there's a variable called j, such as j is equal to 9, and it should multiply 8 times 9. If I did that, that would be one thing, that would work. But if I have not defined j, then this will give me an error. Whereas if I remove this, then Python knows to interpret that j as the square root of -1, and it gives me a complex number. What if I add B plus D? What is going to be the type of that? An integer plus a complex number. You guessed it, it's a complex number. Okay, next is the Booleans. So Booleans are extremely important in programming, and this is a data type that can only take on two possible values, true or false. And in Python, we capitalize our true and false. Finally, the none type. Well, this isn't really a data type. It's rather like a flag that is indicating that a variable has not been given a value yet. So let me show you what I mean by that. So we have, let's say we have a variable that is called age, and that should be equal to the age of a person, so it could be 47.3, and it's a float, okay? So, but maybe at some point in our program, the age has not been defined because maybe the person has not been identified, or the person has not been born yet, or something like that. Then it would be inappropriate to say, for example, age is equal to negative 4, or even age is equal to 0, because that could have some interpretation. Rather, we might say age is equal to none, and that would indicate to other programmers or to the users of the program that the variable age does not have a valid value yet. Okay, so those are the scalar data types. In the next video, we will see how we can use them to do some useful computations.